Section 2.3 and 2.7 Quadratic Functions and Their Zeros, Part 7. Example 7. Hopefully you got a chance to do all of parts A, B, and C. I took the liberty to write up the solutions. Since I already did a few examples, I'm not going to go into detail. We're just going to go over it fairly quickly. So in part A, notice that the quadratic equation does not factor. Therefore, you have to either use the quadratic formula or complete the square. I use the quadratic formula and my zeros are negative 7 plus square root of 61 over 6. And its conjugate, negative 7 minus square root of 61 over 6. Now, in order to graph, it's a good idea to find the x and y intercepts. I already know this is a parabola, so I know what the shape is. I just want to see where the parabola crosses the x and the y axes. Now, I did approximate the values of the x-intercept just because I need to know where they belong on the graph. And I just plug that in my calculator. I also found the y-intercept, so x and y-intercept. So we have our x-intercepts, our y-intercepts, and we just plot them on my graph. And I went ahead and drew the parabola. Since I know it's symmetric, the vertex is somewhere around here. I didn't write it exactly where on the y-axis because you're not going to find the vertex of a parabola until the next section. That's going to be the following lecture. So we'll leave that for now. Okay, but there's your graph. If you need to press pause to check your work, you may do so now. Here's part B. Now, this quadratic equation does factor. Therefore, I simply factor. It's the easiest way to find the zeros. And then my zeros are negative 4 and 3/2. And then again, we want the x-intercepts and the y-intercepts so that we know where the parabola crosses. And the x-intercepts, you just get them directly from your zeros. Moving on, we have part C. Again, this one factors, but because I only have two terms, I have a binomial, I can use the square root method. So I just moved the 25 to the other side and got plus or minus square root of 25, and therefore my zeros are negative 5 and 5. Now note that you could have also just factored this, and this factors to x minus 5, x plus 5. We have a difference of squares. And then we have our x-intercepts and our y-intercept. And then again, we just graph those points, and I know exactly where the parabola crosses. Finally, we have, there's two more examples. In example 8, we want to find where these two parabolas intersect. Now, the points where they intersect, at those points, these two equations are going to be equal. So all we have to do now is just set our quadratic equations equal to each other and solve for x. And those x's are going to be the values of the x coordinate for where these two graphs intersect. So I'm just solving for x here. And we're almost done. So because this is a quadratic, I'm going to move everything to the right side. And the reason I choose the right side, because that negative 2x, I don't want a negative on that negative 2x squared. So I'm just going to add it to the other side. And since it's a quadratic, I know that we need to set it equal to 0 in order to solve, and then just combine like terms. So all I did was add the 2x squared and the 6 to the right hand side. Okay, so now we have this quadratic equation that we've been solving in the last few examples. All I have to do is factor. Now, first take out the GCF, very important. First thing you always want to do in a quadratic before we do anything else. So it turns out this one does factor, so I don't have to complete the square and I don't have to use the quadratic formula either. So we're just going to go ahead and factor this. And as you can see, we get two answers. We get x equals -2 and x equals -1. Now these are only the x values, and in the question, we are being asked to find the points. So these are not points. So in order to find the points, we do have to plug these back into the original functions. Now, it doesn't matter if you plug them into f or g, because at these values, your graphs intersect, which means that they are exactly the same. So I'm going to just plug them into f. If you want to, you can plug them into g and see if you get the same answer as me. You should. There is no reason why you shouldn't get the same answer that I do, and that equals 0. And then f of -1. And again, if you plug it into, oh, you know what? I'm going to do g of -1 so you can just see that it doesn't matter where I plug it in. 3 -1 squared plus 5 times -1 minus 2 equals 0. So that's 3 minus 5, that's -2, and -2, why did I put equals 0? Excuse me, I'm looking at the top equation. So that's 3 minus 5 is -2, and -2 minus 2 is -4. So we have our 2 points. The first point of intersection is -2, 0. That's one answer. And the next point of intersection is -1, -4. And we have one more problem. Before I do this problem, I do want to mention something. If you are standing on top of a mountain, let's say, and you kick a rock, okay? So when you kick the rock and it lands here, what do we know about its height? Well, when the rock falls to the ground, we know the height is 0. That's going to be important for our next problem. It says a ball is thrown vertically upward from the top of a 96 feet building with an initial velocity of 80 feet per second. The distance s in feet of the ball from the ground after t seconds is given by this quadratic function. Now, remember that s of t is the distance in feet, so you can think of this as height if you want to. Okay, after how many seconds does the ball strike the ground? After how many seconds will the ball pass the top of the building on its way down? So let's look at A. So A is asking what is t, because it's asking for seconds, and we know seconds is time. When or after how many seconds does the ball strike the ground? So what is t when h equals 0? So the ground, meaning that its height is now 0. So, oh, and in this case, by the way, height is given as S of t. So we're going to write it as S of t. So we want to set our quadratic equal to 0. Okay. So now we're trying to solve for t, but again, like I mentioned before, when you factor, the very first thing you want to do is you want to take out the greatest common factor. And in this case, it is 16. So if we factor out 16 from the 96, we get 6. And then if you factor out 16 from the 80, we get 5t, and then finally t squared. And then we're going to factor this. So I know it's kind of weird because we have the t on the far right. We can rearrange that if we wanted to. So what two numbers add up to 5t to 5 but multiplied to give you 6? So that's fairly easy. Okay, and then we do want one negative and one positive. So which one is negative and which one? So see, this doesn't work because outer times outer is negative 3t and inner times inner is negative 2t. So that gives us negative 5. That doesn't work. So actually 3 and 2 will not work. You want to use 6 times 1. So first times first gives you 6, and 6 minus 1 gives you 5t. So that'll work. Let's go ahead and erase that. Okay. And then again, one of them has to be negative, one of them has to be positive. So I know this one's negative and this one's positive because we want first times first is 6, outer times outer is positive 16, inner times inner is negative t, and last times last is negative t squared, and that gives us 5t. Okay. So we get two answers. We get that t is equal to 6 and t equals negative 1, but time cannot be negative. So our answer is 6. So after 6 seconds, the ball strikes the ground. Next, we have after how many seconds will the ball pass the top of the building on its way down? Well, let's see. The building was 96 feet. So a ball is thrown vertically upward from the top of the building 96 feet. I'm going to have to stop there because this video is too long and I won't be able to upload it. And stay tuned for the last question.